single phase semi-converter FET DC drive. It is otherwise called a one quadrant converter. So this is called a semi-converter because we have two thyristors and two diodes. This is called a semi-converter, and the load is nothing but a DC motor. So this is a armature part, and this is field part. This field is excited separately. Now coming to the waveform, Vs is the supply voltage, Vm sin omega d. So that is a sinusoidal voltage. Now this thyristor T1 is triggered at an angle of alpha. Let us take during positive cycle of the input cycle, thyristor 1 is forward biased. During a negative cycle, thyristor 2 is forward biased. Now during positive cycle at an angle of alpha, thyristor T1 is triggered. So here T1 is triggered. Here T2 is triggered. Again T1 is triggered. So this sequence is repeatedly happen. When thyristor T1 is triggered, the power supply, that is the load current, will flow through thyristor 1, then through the load, then through diode 1. So in this way there is a load flow. So that time thyristor 1 and diode 1 are conducting. Thyristor 1 and diode 1 are conducting. So that time the output voltage is nothing but armature voltage, that is following the input voltage. The input voltage is a sinusoidal. So that is sinusoidal voltage it will follow. During negative cycle of the input supply, thyristor T2 is triggered at an angle of pi plus alpha. So again the output voltage Va follows the input. So in this way it is going. Now again after some time again positive cycle happen. So thyristor T1 is triggered at an angle of 2 pi plus alpha. So that time thyristor 1 and diode 1 is conducting. Now coming to the next waveform, here this armature inductance is chosen such a way it will provide the constant current. So therefore the armature current is a constant one. So Ia is nothing but a constant one. It is otherwise called, we can say, it is a continuous current conduction. Right. Now coming to the IT1, thyristor 1 current. So the thyristor 1 is conducting over this period, that is alpha to pi. So from alpha to pi we have the conduction. Right. Now again coming to the next one, that is a freewheeling diode conduction. So the freewheeling diode is conducting only this area, that is in this area, that area we have the current flow. That means when no thyristor is conducting, when no device is conducting, the load delivers the current through this. The load current is flowing through this freewheeling diode. So that freewheeling diode current is given like this. And of course the last one is a source current waveform. The source current is when thyristor 1 is conducting, when thyristor 1 and the diode is conducting, so the source current is like this way. So in this way it is going. When thyristor 2 is conducting, so that time the current flow is in reverse direction, that is going in this way, and the diode 2 coming like this, and diode 2. So both the positive cycle and negative cycle, both the source currents are opposite manner. So that opposite manner we can draw like this. Source current is Ia, that is when thyristor 1 is conducting. Again source current is Ia when thyristor 2 is conducting, that is in the negative cycle. So this is the waveform of a single phase semi-converter FET DC drive. Right. Thank you. Now we need to calculate the output voltage equation, that is average output voltage, otherwise we can say armature voltage Va. So this is the waveform of armature output voltage which we have seen previously. So for this we will take one pulse, that is one period, alpha to pi plus alpha. that is alpha to pi plus alpha. So the difference is, we can say as pi. So among when we see the difference, the pi is the base value. So the average output voltage is area by base. So that base value we can substitute as pi. So area is nothing but integration. So integrate the limit alpha to pi plus alpha. So alpha to pi plus alpha. Again, in this period the waveform nature is a sinusoidal. So Vm sin omega t, sinusoidal nature. So the limit is reduces to this pi plus alpha, limit is reduced to pi, because from pi to pi plus alpha there is nothing is present. So the limit, upper limit is reduces to pi. Now this Vm we can take outside. So when we simplify this expression, we have armature voltage is equal to Vm divided by pi 1 plus cos alpha. Now again the next one is from the circuit arrangement, we have the after the armature voltage, after the output of converter is a VA armature voltage, that is given to the DC motor. This is a model of the DC motor. So therefore, from using Kirchhoff's voltage law, that is applied voltage is equal to IARA plus a voltage drop in the inductance and a back EMF. So this voltage drop inductance we will take as this inductance will act as a short circuit. So at a steady state, this inductance will act as a short circuit. So that voltage we will not take, right? Now, so therefore applied voltage is equal to IARA plus back EMF. Now for this VA you can substitute Vm pi 1 plus cos alpha. Now this is one expression. So next one is back EMF for a motor, DC motor. Back EMF is proportional to speed, that is a radian omega m. To remove the proportional, adding the constant Km. Km is nothing but a motor constant, and also we know torque is proportional to Ia, armature current. So again proportional constant is Km. So again this we will take this equation. So this equation, that is VA is equal to IARA plus EB. So this for this EB we will substitute a Km omega m. So from this expression you brought a omega m alone left side. So this is equation. Again torque for this Ia, for this armature current, Ia is equal to T divided by Km. Ia is equal to T divided by Km. Now when we simplify here, left side we have omega m, again VA by Km minus RA Km square into T. So this expression is nothing but we have the equation, famous equation, V is equal to mx plus c. So y-axis we have omega m, and x-axis we have torque. So x-axis we have torque. So this is a famous straight line equation. So here the m constant is a negative constant. So this is a m value. This is m value. That is a negative slope. So negative slope we have, that value is RA divided by Km square. So this C is nothing but y intercept, here VA divided by Km. So this value is VA divided by Km. So therefore this is a torque speed characteristics of any DC motor, which is a negative slope, negative straight line graph. Thank you all.